In this example, we would like to solve an equation involving multiple logarithms. First, what we want to do is remember how the rules of logarithms work. Okay? The first rule in solving this equation that we want to use is the product rule for logarithms. Since all of these logarithms have the same base, on the left-hand side, I can combine these two expressions using the product rule for logarithms. So I get log base 2 of x squared plus 2x, where I multiply this x times this x plus 2. On the right-hand side, I now have log base 2 of 6x plus 1. Since a logarithm is a one-to-one function, I can then equate this x squared plus 2x to this 6x plus 1. This is called the one-to-one property of logarithms. I now have x squared plus 2x equals 6x plus 1. I've now broken this problem down into a quadratic equation, which I can use any of my quadratic equation solving tools. In this case, I would like to get one side equal to 0 and then apply the quadratic formula. I have x squared, 2x minus 6x, that's minus 4x. Subtract 1 from both sides, and now I have 0. Okay, I need to make some room, so I'm going to work up here. All right. Notice that A is 1, B is minus 4, and C is minus 1 if I'm going to use the quadratic formula. So I have x is equal to negative of negative 4 plus or minus the square root of minus 4 squared minus 4 times A, which we said was 1, times C, which we said was minus 1, all over 2A. So 2 times 1. I can make some room here. Okay, this gives me x equals positive 4 plus or minus the square root of 16 minus 4 times minus 1, that's a positive 4. So I have plus 4 in the radicand over 2. I can then continue to break this down to 4 plus or minus the square root of 20 over 2. I can continue to break this down. This isn't simplified enough quite yet, so let me just work over here. I now have x is equal to 4 plus or minus this 20. Think of this as 4 times 5. I can take the 4 out of the square root, so it turns into a 2 square root of 5 over 2. Or more simply, if I divide everything by this 2, I finally get x is equal to 2 plus or minus the square root of 5. Now remember that in dealing with a logarithmic equation, you have to be very careful about your final answer. You may have an extraneous solution. Okay? So let's keep in mind these solutions for just the time being. And let's examine them. Okay? Notice that we have this solution x equals 2 plus square root of 5, and the separate solution x equals 2 minus the square root of 5. Okay? 2 plus square root of 5, this is a positive number because the square root of 5 is a positive number. However, 2 minus square root of 5, this becomes a negative number because the square root of 5, of course, is greater than the square root of 4. So 2 minus a number larger than 2 will give you a negative number. So my point is that since this is a negative number, this will cause a problem when we go back to plug this into the original equation. In fact, the first expression as in the original equation, remember we had log base 2 of x. If I go to plug in a negative number to this, I'll get a problem, which means that this solution actually doesn't work for our particular equation. In fact, if you were to go back and double check, you would see that this solution is extraneous, whereas this solution here is in fact the correct solution. So x equals 2 plus square root of 5 is our solution. Using the techniques of solving a logarithmic equation and the product property of a logarithm, we were able to solve a logarithmic equation involving multiple logarithms.